Hello friends, in this video we will discuss about the multicast routing. Make sure that before you have gone through the IGMP video because this topic is very much dependent on that. Okay, so let's start. So what is the multicast routing? So when let's me make a network that this was a multicast host and these are another multicast host and let's say there is also a multicast host having other multicast host like this, and there are some group related to each. These are the groups related to each. Okay, and with the help of the IGMP, all these have a list. Which have some information about the all this list, all these list have the information about that where to share, where to share, where to not share, where to not share. Okay, so let's think that in this list there is information of all these three have info. Okay, and in this list there is information of all these three groups. Okay, but if this router have any data to be sent here, then there must be also this information with this. So these type of work are done with the help of multicast routing. Okay, so there are the some another list are to be maintained, which we will discuss later. So for this thing if we take some example, that is also known as CTD. Let's say there are 4 students in a class. This one learn chapter 1, this one 2, this one 3, and this one 4. And then what is happening that the first student is teaching first chapter to all, second student is teaching second chapter to all, and third student is teaching third chapter to all, and fourth student is teaching fourth chapter to all. Something this type of the work is done among the routers by using the multicast protocol. Okay, and multicast protocol simply see about the optimal routing, which is also defined as the shortest path. So for this, information is stored with every router regarding the shortest path tree. Okay, and this tree is to be considered as source as root, and some other nodes which are also subsources, and the final destination at the leaves. Okay, so as we know that there are the routers of various type. So there are these multicasting routing with the for unicast routers is of different type, and for multicast is of different type. And in again the multicast there are the two types. One is the source based tree. Source based tree. And another is the group shared tree. Group shared tree. Okay. So let's see for the unicast. Here we are considering R1 as our root, and so it will have a database having the shortest path for these another interfaces. So for uh, let's take me let's me take highlighter. So for n1 there is no any hop between, so it will direct to go. Okay. For n2, which will be the shortest path, so path through the R2 it will be the shortest, so the next hop is R2. And let's take for R3, the next n3, for this the next hop should be R2. And for n4 the next hop should be R2, as it will go to our R2, and then in this table which is present in R2 it will be decided that it should go R3. Okay, so for this R1 it will be only R2. For n5 there is no next hop, and for n6 the next hop is the R4. Okay, so in unicast something like this shortest path tree table is maintained. Okay, now let's see for the multicast. So as multicast we have discussed, these are the two types of the tree records. One is the source based tree. Another is the group shared tree. Group shared tree. Okay. So if we see the source based tree, so is it for the multicasting in the sense of IGMP, means the info is to be sent to the groups, not only single interface, as here this was to be sent to the single interfaces n1 n2 n3 like that, but here the info is to be shared among the groups. Okay, so we are again taking R1 as our root and these groups at our leaves. Okay, so for the G1 group, so where the G1 is present, here it is the G1, here it is the G1, and here it is the G1, and here it is the G1. So for at the R1 the next hop will be nothing for this G1, that it can be sent directly, and R2 for this G1 and this G1, because the next thing will be determined when it comes to here, that R2. When it comes to R2, then here that again this table determine that for one G1 it should be nothing, and one G1 it should be R3. But corresponding to R1, the shortest path, for the shortest path next hop should be R2. Okay, then if you are considering the example of G2, so G2 is present here, here, and here, then again the path will be, and okay, one thing I have left, that G1 was also present here too, so it was also including the R4. Okay, so G2, for G2 it should go next hop at R2, and for G3 it should that G3 is present here and here. So one thing, that no any next hop, so it will can directly send, and for this G3 it should go here at R2. Then G4 is present here and present here, so for this group it should send R4, and for this group it should send R2. Then G5 is present here and present here. So for this G5 it should be transferred to R2, and for this G5 from here data should be transferred to R4. So it was all about the source based shortest path tree tabulation maintenance. Now comes to the group shared. In group shared there is no any of these router make at root. There is a center core router which is make at root, and any other routers are something like that. The next hop are the internal nodes. So it is the center core router, and if and the that shortest path database will be along with this only. Okay, so if the group is G1, so where it should go? G1 is present here and present here and present here and present here. So it can also be sent directly for this, for here. Okay, it can be sent directly for here, and for here it can be sent to the R2, and for here it can be sent to the R3, and for here it can be sent to the R4. And similar to this, you can also check for all these groups. So that was all about the multicast routing of that information which has been collected through the IGMP. Okay, thank you. Bye bye. Take care.